Hello and welcome back. In 2.7, we get to work with marginal analysis. So marginal is a rate of change. Ends up being a good topic to look at in a calc course. So for example, marginal cost is instantaneous rate of change, ROC, in the total cost. Yeah, whatever production level. And similar ideas exist for marginal revenue, marginal profit. They're the instantaneous rates of change at whatever production level or sales level. So if C of X is the total cost to produce X items, then the cost of the X plus first item would be C of X plus 1, so the total cost of making X plus 1 items minus C of X, the cost of making the first X items. The marginal cost, this would be an exact. It's an approximation of the exact, and it's, I'm told, more frequently used in business. Would be C prime of X. So we're approximating it as C of X plus delta X minus C of X over delta X, and we let delta X equal 1. We're going to produce one more unit. So it doesn't make sense to make delta X go to 0 like we typically would. The fewest number of things we can make is 1. We can't produce 0 more things and claim that we've changed anything. To make a change, we have to make at least one additional item. So if delta X is 1, then C prime of X, approximately the C of X plus delta X minus C of X. All right, so let's actually work with an example here. So we'll take a look at C of X, 12,000, so that's our fixed cost, plus 160x minus 4/10 of x squared. So the second two terms are the variable cost based on how many items produced. So we'll find the exact cost 141st item. And then we'll also find the marginal cost. Approximating the cost of the 141st item. So for the exact, I would find C of 141, cost of producing 141 items, so 12,000 plus 160 by 12, or by 141, minus 4/10 of 141 squared. So C of 141, 26,607.60. We assume that we're working in dollars unless specified otherwise when we're talking cost, revenue, and profit. C of 140, similar idea, 12,000 plus 160 by 140 minus 4/10 of 140 squared. So the cost of producing 140 items would be 26,560 even. So our exact cost of the 141st item will just be the difference. So 26,607.60 minus 26,560. So our exact cost is $47.60. So next we want to look at the marginal cost. The marginal cost, remember, is estimating what the exact cost would be. So that is a derivative. So let me sort of transfer the relevant pieces to the top of this page. C of x, recall 12,000 plus 160 times x minus 4/10 of x squared. So we'll need C prime. So C prime, derivative of a constant, is 0, no matter how big or small that constant may be. Derivative of a linear is a constant, so 160. I'll hang on to the minus 4/10. The 2 exponent becomes the 2 factor. Hang on to the base. Drop 1 off of your exponent. So C prime of x is 160 minus 8/10 of x. So we're looking for the marginal cost to approximate the cost of the 141st item. Well, that would be the rate of change at the 140th item. However much it's changing by at 140 is what we would expect the 141st to come up with. So we're going to do C prime of 140. So 60 minus 8/10 of 140 is 48 even. So our exact was $47.60. Our estimate, using marginal cost, for the 141st item. Very close together. Difference of 40 cents, very close to the original. Very reasonable estimate. All right, so next we get to work with the price demand equation. So X will be units demanded. And for whatever it is we're selling here, 13,000 minus 1,000 P. So how many units demanded at a given price point. In other words, each time the price goes up by $1, in this case, the demand will go down by 1,000 units. So just think of it as a linear equation. Negative 1,000 over 1, you can always think of it as over 1 is the slope. Each time the price increases by $1, demand drops by 1,000 units. So we can also rearrange this to isolate P. So X minus 13,000 is worth negative 1,000 times P. So then P, dividing both sides by negative 1,000, is negative 1/1000th times X. And then negative 13,000 divided by negative 1,000 is plus 13. So let's further suppose we have a cost function. So let's suppose C of X is 5,000 plus 4X. All right, we're out of room on here, but we will continue this one on the next page. So we'll start this by finding the domain of the price demand equation. So recall that our price was negative 1/1000th of X plus 13. Price is at least 0. So negative 1/1000th of X plus 13 is also then at least 0 by substitution. So let's see, so 13 is at least 1/1000th of X. So 13,000 is less than or equal to X. We can't make a negative number of units. So number of units is non-negative. X is the number of units. So we can conclude then our domain, apologies, I bumped the camera stand there. So our domain, little x, such that x, and we'll call it the real numbers. It's really, we could narrow it down to whole numbers. 0 less than or equal to X less than or equal to 13,000. So that's the limit on the number of units in this particular problem. Let's see, what else are they going to ask us to do with the same one? Find and interpret the marginal cost function. So recall from the previous page, c of x was 5,000 plus 4x. Marginal is derivative. So we're looking for c prime of x. See if you can just pause it real quick and find the derivative. Okay, welcome back. Derivative of a constant is 0. That will drop off. Derivative of a first power is a constant. So c prime of x is just 4. Always 4. So as far as interpreting what that means, so remember this is a rate of change. So as x goes up by 1, x is the number of units being demanded. So is each additional unit is made, cost will, and here we'll want to say increase or decrease, not just change by, but increase in this case since it's positive. Cost will increase by $4. So the next thing we can do, again with the same example, use a little arrow just to indicate that we're still working on sort of a one longer word problem. That is the nice thing about the business calc, is that we do get to work kind of more tangible real life problems than the Calc 1 students. They get to go a little bit deeper into the math behind all of what we're doing. You all get to see sort of more examples. So the third thing they're asking for is for us to create a revenue function. So revenue is just how many items you sell times price. So unit price. So X is in units, price is assumed to be in dollars unless I indicate otherwise on a problem. Recall though, we also figured out how to get P by itself in the other one. So from previous pages, recall P was -1/1000th of X plus 13. So now we can say R is worth X by -1/1000th of X plus 13. And we can do a little simplifying there. So R of X, so the revenue based on items sold, -1/1000th of X squared plus 13 times X. Now, since the domain for the price demand equation was on 0 to 13,000, this revenue is also only valid for 0 to 13,000. Unfortunately, with the bigger numbers, we kind of have comma playing double duty here. This one is separating our X and Y. This one, because we have a digit that's more than 4 numbers long. Or not a digit, a number that's more than 4 digits long. So that is our revenue function. Okay, so I'm going to ask you to pause it and find the marginal revenue function. Okay, so welcome back. Marginal, hopefully you remember, means rate of change. So we're looking for r prime of x. I'll keep the -1 1,000th, multiply by 2, x squared is now x to the first. 13x, derivative of a linear, is always a constant. So r prime of x, playing a little cleanup, -1 500th of x plus 13. I'll also ask you to find and interpret the marginal revenue at 10,000 units. So go ahead and pause it. See if you can find that and also figure out what it means. So not just can you find the number, can you tell me what that number is telling us? Okay, welcome back. So the first part of the problem, find the marginal revenue. We're just finding r prime of 10,000 then. So -1 500ths times 10,000 plus 13. Let's see, so that'll knock 2 zeros off of there. So then we have 2 zeros off of there. 100 divided by 5 is 20, so -20 plus 13 is -7. Okay, so r prime at 10,000 is -7. So at 10,000 units, sold, revenue is decreasing at $7 per additional unit. See if we can repeat that for 5,000 units, and you should see an increase of revenue per additional unit. We're going to move on a little bit though. We're going to find the, again, continuing the same problem, we're going to find the profit function. So profit, remember, is just money coming in minus money going out, revenue minus cost. So take a moment, thumb through your notes, see if you can find the profit function. Okay, welcome back. So P of X, our revenue we figured out was -1 1,000th of x squared plus 13 times x, minus our cost was 5,000 plus 4x. It's more than one term I'm subtracting, so definitely use those grouping symbols. So our profit function, -1 1,000th of x squared. Let's see, we have plus 13x minus 4x, so plus 9x minus 5,000. If I want the marginal profit, then I'm looking for P prime of x. So P prime of x, hang on to the -1 1,000th, 2, the exponent is now 2. The factor, hang on to the base, drop 1 off of the exponent. Hang on to the 9, x to the 0 is just 1, it'll drop off. Derivative of a constant, also 0. So p prime of x, negative 1/500th of x plus 9. So I'm going to have you find the marginal profit at 2 different levels, 3,000 units sold and 5,000 units sold. See if you can also interpret. Okay, so welcome back. So p prime of 3,000, we'll start there. So negative 1/500th of 3,000 plus 9. So that's negative 6 plus 9 is positive 3. And p prime of 5,000, negative 1/500th of 5,000 plus 9. So negative 10 plus 9 is negative 1. Okay, so nice, neat, pretty integer solutions. If we come up with something that has a whole bunch of decimal places and we're talking a dollar amount, we go out to the hundredths, check to see if we would round it up or keep it, and then go to our interpretation. So at 3,000 units sold, profit is increasing by $3 per unit. If the production is, not dollars, is 5,000 units, profit is decreasing by $1 per additional unit. So at 5,000 units, they're oversaturating the market, and the customers are losing interest there. Okay. And the last topic in this section will be the marginal average. So let's suppose C of x will make it, let's say, 2,000 plus 40x minus 2/10 of x squared. Average cost, which is denoted C bar of x, well, this is the cost for x units. So the average cost would be this divided by x. So 2,000 x to the negative first plus 40 minus 2/10 of x. So this is how we would find the average cost. If we want the marginal average cost, just like you expect, where marginal still means rate of change, so derivative. So we do c bar prime of x. So hang on to the 2000. The exponent -1 becomes a factor -1. Hang on to the base. Decrease your exponent by 1. Careful with your sign work there. -1 minus 1 is -2, not 0. Derivative of a constant, always 0. And derivative of a linear is always its coefficient. So the marginal average cost is measured by c bar prime of x, -2000 x to the negative second minus 2/10. So if we wanted to look at, let's say, c bar of 10 and c bar prime of 10. In fact, I'll have you just pause and try those out. Okay, welcome back. So c bar of 10, we're just plugging into the average cost function. So 2000 times 10 to the negative first, so in other words divided by 10, plus 40 minus 2/10 of 10. So 2000 divided by 10 is 200, plus 40, 240, and then 2/10 of 10 is 2, so we have, let's see, so that's 240 minus 2, 238. So at 10 units produced, cost averages $238 per unit of whatever we're making. Then on to the c bar prime. One little note on here, the order that we do this is not commutative. You have to find the average cost first, then the marginal average. You can't find the marginal cost and then divide by x. It's not commutative. You do have to find the average first and then find the marginal average cost. So c bar prime of 10, let's see, -2000, 10 to the negative second, so in other words divide by 100, minus 2/10. So negative over positive is a negative, and 2000 divided by 100 is 20, so -20 minus 2 is -20 and 2/10, or -20. So similarly, at 10 units produced, average cost, marginal cost, I should say, average marginal cost. Negative this time, so decreasing as opposed to increasing by $20.20 per unit. So that 11th item is going to be bringing our average down almost $20. Okay, so in 2.7, I would recommend 1 to 27 on the odds, 33, 37, 43, and 47. If you have questions, please get in touch with me. Otherwise, I will see you next time, and stay safe out there.